To understand the logistical puzzle of India, look at the extremes. Between the sheer vertical climbs of the Himalayas and the dense, unbroken canopies of the Andaman forests, the geography is unforgiving. These environments physically isolate millions of people. Essential medical supplies and critical agricultural routes are cut off simply because standard paved roads cannot be built there. Helicopters seem like the obvious answer, but their massive fuel consumption and strict maintenance requirements make daily routine supply drops financially impossible. Standard multi-rotor drones have the opposite problem. They hover perfectly in tight spaces, but their batteries drain far too quickly to cover meaningful distances. Traditional fixed-wing airplanes solve the distance problem, but they require long, flat strips of asphalt to take off and land. That infrastructure doesn't exist in remote mountain villages. Bridging this gap requires a completely different class of aircraft, one that ignores the limitations of both runways and short battery life. This is SP Drone's localized answer, the SP7007 Janot. To navigate these specific barriers, engineers had to discard traditional aviation design and construct a hybrid platform from the ground up. To start, the SP7007 carries a massive physical footprint designed for heavy lifting, spanning 2,235 millimeters from wingtip to wingtip. The airframe utilizes a high-tensile, low-weight philosophy. The aerodynamic surfaces are built around a balsa wood core, chosen specifically to dampen high-frequency motor vibrations. That skeletal frame is then reinforced with high-strength aluminum tubes, ensuring the structure handles the intense 11.5 kilogram dynamic load during vertical ascent. Instead of a rigid single-piece body, the drone uses a modular design, allowing field engineers to quickly assemble it from transport mode to flight-ready. By combining the natural resonance absorption of balsa with the brute strength of aluminum, the frame maintains exact rigidity in turbulent, off-grid environments while keeping the total weight low enough to carry 800 grams of cargo. This technical infographic details the core innovation of the Janot, a decoupled 4+1 propulsion architecture. The 4 represents the vertical lift. 4 high-torque T-motors provide enough upward thrust to lift the entire chassis straight up, eliminating the need for a runway entirely. The 1 represents the fixed-wing cruise. Once the drone reaches altitude, a single forward-facing high-efficiency motor engages to push the aircraft horizontally. This chart shows how the system conserves battery life. You see a massive energy spike to lift the heavy drone off the ground. Once it transitions to forward flight, the 4 vertical motors shut down entirely, dropping the power draw to a low, sustained baseline. Because of that energy efficiency, the SP7007 maintains a continuous cruising speed of 20 meters per second for over 30 minutes on a single charge. By decoupling lift from thrust, the 4+1 design borrows the vertical agility of a helicopter and applies it to the endurance profile of an airplane. This hardware requires precise management. The aircraft is governed by the Pixhawk Cube Black, a professional-grade, triple-redundant autopilot system. Operators draw polygonal survey areas on a ground station computer. The drone calculates the grid and executes the flight autonomously. For navigation, it relies on a HERE-2 GNSS system, a global satellite receiver processing multiple networks simultaneously to ensure redundant pinpoint location tracking. To keep the ground station connected to that complex web of speed controllers and sensors, the drone utilizes an RFD 900+ telemetry modem, securing a stable data link even at extended ranges. Integrating high-end avionics with heavy-duty telemetry makes the SP7007 a reliable asset for professional data-gathering missions. Designed and manufactured entirely in Mohali, Punjab, the SP7007 is a direct realization of the Make in India initiative, proving domestic engineering can compete in the aerospace sector. For rural agriculture, this means farmers can bypass broken or non-existent infrastructure, flying their high-value produce to local markets in a fraction of the time. For civic applications, the payload bay accommodates cameras for high-precision 3D mapping of difficult terrain or essential medical supplies required instantly in isolated zones. Complex logistical barriers don't automatically require expensive imported technology. Localized engineering is uniquely equipped to solve localized geographic challenges. Building the hardware is only half the equation. SP Drone provides a complete operational ecosystem to ensure users can pilot these advanced machines safely. Before risking physical hardware, Operators undergo certified ground school and master complex flight maneuvers inside a dedicated digital simulator. Beyond the SP7007, they engineer customized multi-motor platforms, run extensive aeromodeling workshops, and pilot professional aerial airshows for large-scale events. To integrate advanced VTOL technology into your own operations or book a customized aerospace build, call 978-061-273 or visit spdrone.tech. The tools to bypass India's toughest terrains are already built, tested, and waiting for the next generation of aviators to put them to work.